Dear student, in a last video related to Kirchhoff's law and Wheatstone network, by using Kirchhoff's law, two important law, one is called a junction rule and the one is called a loop rule. By using that, we consider one important type of network we call it as Wheatstone network or Wheatstone bridge. By using Wheatstone network or Wheatstone bridge, we got the balanced condition. Under balanced condition, we got the condition like this: P divided by Q is equal to R divided by S. By considering four resistors P, Q, R, S, they are connected in the form of cyclic order in the form of quadrilateral. And by using that, we got the balanced condition: P by Q is equal to R by S. In that balanced condition, current flowing through a galvanometer becomes zero. That I clearly explain. Not only that, I explain sign convention in case of Kirchhoff junction rule as well as in case of Kirchhoff's loop rule. Those things we learn in our previous videos. Today we do the continuation of that. We start with the new concept like meter bridge. Dear student, related to meter bridge, in a second PUC, we are going to discuss nearly four important experiments. One is related to series and parallel combination of resistor, and the one is related to resistivity, to calculate the resistivity of the material of a wire. We are going to make use of the device called a meter bridge. Dear student, this instrument meter bridge or concept meter bridge is mainly depending on a Wheatstone network or Wheatstone bridge. Not only that, by using Kirchhoff's law, we are going to think of meter bridge. First important thing is application part of meter bridge, or what is the meaning of meter bridge. Here meter bridge is the device. It is the device. It is the device used to find unknown resistance. It is a device used to find unknown resistance. It may be unknown resistance of a wire, and by using this unknown resistance, one can easily find out the resistivity of a given material of a wire. That's why meter bridge is the device used to find the unknown resistance of a material of a wire or resistivity of a material of a wire. That's why it is the device used to find out unknown resistance in a given system or a given material of a wire. Dear student, meter bridge experiment we are going to use to find out the unknown resistance and also to calculate the resistivity of a material of a wire in a lab. And again, the same setup, meter bridge, used to verify the series and parallel combination of a resistance in second PUC physics lab. Dear student, this one is the setup. Meter bridge setup. It looks like this. And the same setup you're going to use in a lab. I will draw the diagram. After writing the diagram, I will explain how all the knobs works and how this circuit works. That I will explain later. First, I will draw the diagram how the meter bridge looks. Dear student, the diagrammatic representation of meter bridge is like this. It containing two L-shaped metal strips like this. It containing two L-shaped metal strips. Is a one L-shaped metal strip. It is the another L-shaped metal strip. In between two L-shaped metal strip, it containing one more metal strip like this. One more metal strip like this. And this particular point in L-shaped metal strip, I call it as A. This particular point in L-shaped metal strip, I call it as C. And in between A and C, we have to connect one wire of length L. The length of this wire in a meter bridge is equal to 1 meter. That's why that instrument is called meter bridge. This length is equal to 1 meter. AC is the length of the wire. Its value is equal to 1 meter, is also equal to 100 centimeter, is equal to 1 meter, and that's why that instrument is called a meter bridge. Here AC is the length of the wire. Total length of the wire is equal to 1 meter. Again, in this setup, I already told there will be two L-shaped metal strips. These two are the L-shaped metal strip. In between that, it containing one more strip like this. It containing two gap. One we call it as left side, and the one is called right side. There will be a two gap like this. I consider it is the one point, and it is another point, is a one more point, and it is a one more point like this. It contains two gap. And again here, the middle point I denote, that middle point I denote it as B. B is the middle point. And this point B, with the help of wire, it is connected to, with the help of wire, it is connected to galvanometer, and again it is connected to one more instrument. That arrow mark indicates slider, is also called jockey. Slider or jockey. Slider or jockey is the one, it will ride over this length of the wire. That's why it is called slider. It is sliding over this length of the wire or riding over this length of the wire. That's why it is called slider or jockey. This particular point we denote it as D. Here I indicated 4 points. One is A, and the one is B, and the one is C, and the one is D. It contains two L-shaped metal strip. In between that contains one more strip, and again that middle point of that middle strip, metal strip, it is taken as B. It is connected to a galvanometer. Galvanometer is a device used to detect the flow of current in a circuit. Again it is connected to one more terminal. That terminal is called slider, is also called jockey. Here arrow mark indicates slider or jockey. It contains 4 corners. A, B, C, D are the 4 corner. Dear student, in case of Wheatstone bridge also we learn 4 corner A, B, C, D are connected in a cyclic order in the form of quadrilateral. That I already explained. Same way here, 4 corners A, B, C, D are connected in a cyclic order in the form of quadrilateral. Again there will be 2 gap, I said. One's left side gap and the one is right side gap, and this particular gap is connected to unknown resistance. That I call it as, this particular gap is connected to unknown resistance. That I call it as R. R is the unknown resistance that you want to calculate. This gap is connected to unknown resistance. This particular resistance is called unknown. It is called unknown resistance. This unknown resistance value you have to calculate. Once you get the value for this unknown resistance, we can easily find out the resistivity of the material of a wire. And not only that, again this terminal is connected to one resistance box. I already explained in electric current topic itself how the resistance box looks under color code of resistor. I clearly explain under resistor and color code of resistor how the resistor box indicates. This resistance box is denoted as S. Is a suitable value, I denote it as S. S is the variable value of resistor box. We say that resistor box. And 2 gaps are there, and 1 gap is connected to a wire of suitable resistance R. Its value is unknown. That you have to calculate. Innondu side, innondu gap, it connected to a standard resistance box. We call it as S, is also called resistance box. Its value going to change from trial to trial. Trial in the trial you change ಮಾಡ್ತೇವೆ. Again 2 more terminals are there. It is nothing but A and C. Corner A and C. Corner A is connected to a cell or a battery of suitable EMF or voltage. I denote it as V, or you can take it as E also. If it is the cell, it got a suitable internal resistance. Or you may connect a battery also with the help of key, where K represent the key, and this terminal is connected to a end or corner C. And this complete circuit we call it as meter bridge. Dear student, in a meter bridge, it containing two L-shaped metal strip. In between that, it containing one more metal strip. The middle point of that metal strip we call it as B. It is connected to a galvanometer. It is a device used to detect the flow of current in a circuit, and again it is connected to a terminal or arrow mark here. That particular arrow mark, it is called slider. The component is called slider or jockey. The slider or jockey is the one is sliding from along the length of the wire from A to C. It is also called slider or jockey. It is riding from A to C to get the balancing length. Again, corner A and C connected to a battery of suitable potential with the help of key, and is connected to a terminal or corner C. This one is the diagrammatic representation of meter bridge. Dear student, this one is the meter bridge instrument. ಇಲ್ಲಿ ಏನಿದೆ ಕೇಳಿದ್ರೆ, I already told meter bridge ಅಲ್ಲಿ L shaped metal strip ಇದೆ ಅಂತ ಹೇಳಿದೆ. It should be like this. ಇದು L shaped ಒಂದು metal strip. See this. L shaped ಒಂದು metal strip. ಈ metal strip ಅನ್ನ I denote like this. ಇದು L shaped ಒಂದು metal strip. ಇನ್ನೊಂದು L shaped metal strip ಇಲ್ಲಿದೆ, ಚೆಕ್ ಮಾಡಿ. ಇದು ಇನ್ನೊಂದು L shaped metal strip. I call this particular point is A. ಇಲ್ಲಿ ನೋಡಿ, A ಇದೆ. ಇನ್ನೊಂದು ಎಂಡಿನ metal strip ನ end C. ಇದು C ಆಯ್ತು. ಇದು A, ಇದು C. A ಮತ್ತೆ C ನಡುವೆ there will be a wire of unknown resistance. See this, ಇದು wire ಇದೆ, ಇದರ resistance ನಮಗೆ ಗೊತ್ತಿಲ್ಲ, or you can calculate by using this instrument itself. ಇದರ length ಇದೆ, ಇದು wire. ಆ wire ಕೆಳಗಡೆ scale ಕೊಟ್ಟಿದ್ದಾರೆ. just see that. ಇದು ಈ ವೈರ್ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿದೆ, ಈ ಸ್ಕೇಲ್ ಈ ವೈರ್ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿದೆ. ಇದ್ರ ಮೇಲ್ಗಡೆ ವೈರ್ ಇದೆ, ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ವೈರ್. ಅದರ ಕೆಳಗಡೆ ಸ್ಕೇಲ್ ಇದೆ. ಲೆಂತ್ ಆಫ್ ದಿ ಸ್ಕೇಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 meter. ದಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ಲೆಂತ್ ಆಫ್ ದಿ ವೈರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 meter. ದಟ್ಸ್ ವೈ ದಿಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಮೀಟರ್ ಬ್ರಿಡ್ಜ್. ಲೆಂತ್ ಆಫ್ ದಿ ವೈರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 meter. ಇಲ್ಲಿ ಎರಡು ಗ್ಯಾಪ್ ಇದೆ ಹೇಳಿದೆ. ಇದು ಮಿಡಲ್ ಮೆಟಲ್ ಸ್ಟ್ರಿಪ್. 3 terminals are there. See this, 1 2 3. A middle terminal we call it as B. It is B. ಇಲ್ಲಿಂದ ಒಂದು ವೈರ್ ತಗೊಂಡ್ರೆ it is connected to a galvanometer connected to one more device we call it as slider. Is also called a jockey or slider. Dear student, this one is called slider. ಗ್ಯಾಲೋಮೀಟರ್ ಇನ್ನೊಂದು ಟರ್ಮಿನಲ್ ಈ ಸ್ಲೈಡರ್ಗೆ ಬರುತ್ತೆ. ಇಟ್ ಇಸ್ ಅ ಪಾಯಿಂಟ್ ಆಫ್ ದಿ ಸ್ಲೈಡರ್. ಇಟ್ ಈಸ್ ರೈಡಿಂಗ್ ಓವರ್ ದಿ ವೈರ್. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ರೈಡ್ ಮಾಡುತ್ತೆ. ಜಸ್ಟ್ ರಿಮೆಂಬರ್, ವಿ ಹ್ಯಾವ್ ಟು ಥಿಂಕ್ ಅಬೌಟ್ ಅನ್ನೌನ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಸುಟೇಬಲ್ ವ್ಯಾಲ್ಯೂವನ್ನ ರಿಮೂವ್ ಮಾಡಿದಾಗ ಆಟೋಮೆಟಿಕಲಿ ಗ್ಯಾಲೋಮೀಟರ್ ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ. ಇಫ್ ಯು ಗೋಯಿಂಗ್ ಟು ಟಚ್ ದಿ ಸ್ಲೈಡರ್ ಆರ್ ಜಾಕಿ ಓವರ್ ದಿ ವೈರ್, ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ. ರಿಮೆಂಬರ್, ಈ ಪಾಯಿಂಟ್ ಇಂದ ಎ ಇಂದ ಹಿಡಿದು ಸಿ ತನಕ ಇದು ಸ್ಲೈಡ್ ಆಗ್ತಾ ರೈಡ್ ಆಗ್ತಾ ಹೋಗ್ಬೇಕಾದ್ರೆ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಡಿ. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಇಲ್ಲಿ ಬರ್ತಾ ಗ್ಯಾಲೋಮೀಟರ್ ಶೋಸ್ ನೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಆರ್ ಝೀರೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಇನ್ ದಿ ಗ್ಯಾಲೋಮೀಟರ್. ಗ್ಯಾಲೋಮೀಟರ್ ಅಲ್ಲಿ ಝೀರೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ ಇಲ್ಲೆಲ್ಲೋ ಬರ್ತಾ. ಅಂಡ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೆಂತ್ ಫ್ರಮ್ ಎ ಟು ಸಿ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೆಂತ್. Dear student, in a Wheatstone bridge itself I said balancing length is the particular length where galvanometer shows zero deflection. That particular point is also called null point. Null point is the one galvanometer shows zero deflection. Dear student, where point D is called null point, where galvanometer shows zero deflection. ಏನು ಡಿಫ್ಲೆಕ್ಷನ್ ಇರಲ್ಲ. ರಿಮೆಂಬರ್, ಇದನ್ನ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಸ್ಲೈಡ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರ್ತೇನೆ. ಗ್ಯಾಲೋಮೀಟರ್ ಕನೆಕ್ಟ್ ಆಗಿದೆ ಈ ಟರ್ಮಿನಲ್. ಇಲ್ಲೆಲ್ಲೋ ಬರಬೇಕಾದ್ರೆ, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟಿಗೆ ಬರಬೇಕಾದ್ರೆ ಗ್ಯಾಲೋಮೀಟರ್ ಅಲ್ಲಿ ಝೀರೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ. ಆ ಝೀರೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಎಲ್ಲಿ ತೋರಿಸುತ್ತೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅನ್ನ ನಲ್ ಪಾಯಿಂಟ್ ಅಂತ ಕರಿತೇನೆ. ಆ ಎ ಇಂದ ಇಲ್ಲಿಗಿರುವ ಲೆಂತ್ ಅನ್ನ ವಿ ಕ್ಯಾನ್ ಮೆಜರ್ ಬೈ ಯೂಸಿಂಗ್ ದಿ ಸ್ಕೇಲ್. ಆ ಲೆಂತ್ ಅನ್ನ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೆಂತ್. Understood? This one is the meter bridge instrument, and same instrument we're going to use in a lab, and this one is called slider or called jockey. We'll do the continuation of this. Again, I already said this particular point we call it as a null point, where we get the current flowing through a galvanometer is zero, and this particular length from A is called balancing length, that we denote it as L. Dear student, Total length AC is equal to 1 meter. I already said 100 centimeter. And balancing length from A to D is equal to L. L is called balancing length by using the null point D, where galvanometer shows zero deflection. And remaining length DC out of total length AC, remaining length DC by removing AD is 100 minus L is in terms of centimeter. 100 minus L in terms of centimeter, it is the remaining length. Dear student, the length of the wire is also provide a resistance, that I already said. You already know about that. Resistance of a wire directly proportional to length of the wire and inversely proportional to area of a cross section, that we already learned. Length of the wire is also provide a suitable value of resistance. Here also length of the wire is there, it also provide a suitable value of resistance. Total in this setup 4 resistors are there. One is unknown resistor, that value you have to calculate, that is connected in this gap. And the one is standard value of resistance box, suitable value of resistance we removed, that is nothing but S. And the one is length of the wire itself, AD, it provides a suitable value of resistance, because as the length increases, resistance of a wire also goes on, increases. Here AD also provides a suitable resistance. And DC, it is a remaining length, it is nothing but 100 minus L. This part is also got a suitable resistance. And this particular circuit exactly equal to Wheatstone bridge, like this. It containing 4 resistor, Wheatstone bridge, like this. It containing 4 resistor are connected in the form of quadrilateral. In between corner A and C, we connect battery with the help of key. This particular point we call it as C. In between B and D, we connected galvanometer of suitable resistance. This circuit you already learned, that we call it as Wheatstone bridge. This particular resistor I denote it as P, this particular resistance is Q, this particular resistance is R, and this one is S, are connected in a cyclic order in the form of quadrilateral. In between corner A and C we connected a battery, same diagram here. In between B and D we connected a galvanometer with the help of slider to get the balancing length. If this Wheatstone bridge is, galvanometer is equal to 0 or no deflection in the galvanometer, automatically rho of P is equal to R, rho of Q is equal to S, rho of R is equal to L, rho of S is equal to 100 minus L. Dear student, remember clearly, ಇಲ್ಲಿ P ಏನು ಕೆಲಸ ಮಾಡುತ್ತೆ ಅದ ಕೆಲಸವನ್ನ R ಮಾಡುತ್ತೆ, Q ಏನು ಕೆಲಸ ಮಾಡುತ್ತೆ ಅದ ಕೆಲಸವನ್ನ S ಮಾಡುತ್ತೆ, R ಏನು ಕೆಲಸ ಮಾಡುತ್ತೆ ಅದೇ ಕೆಲಸವನ್ನ length of the wire going to do. Length of the wire also got a suitable resistance. Length ಜಾಸ್ತಿ ಆದಾಗೆ resistance ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇಲ್ಲಿ S ಏನು ಕೆಲಸ ಮಾಡುತ್ತೆ ಅದನ್ನೇ 100 minus L ಮಾಡುತ್ತೆ. It is also length of the wire. Automatically we can say P is replaced by which one here? R. P is replaced by R. Q is replaced by standard resistance box with suitable value. Yes, again R is replaced by length of the wire, and not only that, we can say S is replaced by, that is nothing but this S is replaced by 100 minus L. 100 minus L. Dear student, according to Wheatstone bridge, under balanced condition, at balanced condition, we got P by Q is equal to what I said, R by S, that you already learn under Wheatstone bridge. At balanced condition you already got P by Q is equal to R by S. By using this logic, in place of P we have to use R, in place of Q we have to use S, in place of R you have to use L, in place of S you have to use 100 minus L, in place of P you have to use R divided by, in place of Q you have to use S, equal to, in place of R you have to use L, in place of S you have to use 100 minus L, 100 minus L. After simplification we got R is equal to SL divided by 100 minus L. Remember, where R is the resistance of a given material of a wire, its value is unknown. By using this formula, we get the answer for unknown resistance. By using this formula, we got the answer for unknown resistance. Once you get the value for unknown resistance, we can easily find out the resistivity of the material of a wire, that you already learned. If you know the answer for resistance of a given material of a wire, we can easily find out the resistivity of a given material of a wire also. That's why meter bridge is the instrument used to find out the unknown resistance of a given material of a wire or resistivity of a given material of a wire. In a lab, this instrument is used to find out the unknown resistance by using same technique, and not only that, one can easily get the answer for resistivity of a given material of a wire. It is the application part of meter bridge. Is that clear? Right. Next part, we are going to discussing about one more instrument called potentiometer. That also we'll discuss in detail. Not only that, there will be application part of potentiometer is there. That also we'll discuss. There are two important application part. That application part we're going to use in a lab to find out the internal resistance of a cell. Not only that, to compare the EMF of a cell. These two application part we're going to discuss in next class under device called potentiometer. Remaining thing we'll discuss in next class. Thank you.